Alright, welcome to a lesson on what we're going to call triangle inequalities. And these are just some special properties that exist with triangles that we're going to go over. So first, here's a triangle. It's a triangle with sides of 5, 6, and 7, angle measures of 42, 59, and 79. Now, what I want you to do is I want you to pause the video and look at this triangle and see if there's anything you might notice. Pay particular attention to sizes of things or how big things are. So go ahead and pause the video and discuss that with yourself or with a partner now. Okay, so I know that's kind of vague what I gave you, but what I was hoping you would see is this. 5. 5 is the smallest side. The smallest side here is also across from 42. 42 is the smallest angle. 7 is our biggest side. If we look across at the angle, it's also across from the biggest angle, and 6 is in between both, and it just so happens that 59 is also in between our angles. So that's what we see happening here. In any triangle you have ever seen, the biggest side is always across from the biggest angle. Just like the smallest side is across from the smallest angle, and vice versa. The smallest angle across from the smallest side, the biggest angle is across from the biggest side. Now, if you think about it, think about that right triangle that we've worked with in the past. Biggest angle here is the right triangle. Well, we know that in the right triangle, the biggest side is always the hypotenuse, right there. So we've actually been working with it, and you just didn't realize it. So, we're going to draw the triangle and name the angle smallest to largest. So we're given the sizes of the triangle, the size of the sizes of the triangle, we're going to draw that triangle. So we don't have to actually draw this for scale, so I'm just going to draw a triangle. And then I'm going to label A, B, and C. And then we just fill in the blanks. So it looks like AB is 10, BC is 12, and CA is 9. And I want to name the angle smallest to largest. Now, if you don't get your picture right, you're going to get your answers wrong. So it's very important that you get your picture right and that you get your drawings all where they need to be. So the smallest side is 9, and I know that the smallest side is across from the smallest angle. So it looks like angle B is our smallest. The next size up is 10, and that's across from C. So angle C, which leaves angle A as our biggest. So there we go. We drew the triangle and we named our angles smallest to largest. So here we're going to draw our triangle and we're going to name our sides from smallest to largest. And I forgot to write that, so I'm going to pause the video and write it now. There we go. The words magically appeared on your screen. So again, we don't have to draw a scaled triangle. We just need to draw a triangle, and then we can fill in the blanks. So measure of angle A is 55, so this is 55. Measure of angle B is 95, so that's 95. And it doesn't tell us what C is, but we can figure out what C is using our triangle angle sum. We know that in a triangle that all the angles add up to 180. So if I do 180 minus 55 plus 95, we'll get our answer. 55 plus 95 is 150, so it looks like C is 30. Alright, so now that we have all of our angles labeled, we can name the sides smallest to largest. So it looks like our smallest angle here is 30. The side across from it is AB. So it looks like AB Next is that 55, and 55 is across from BC, which leaves us with AC or CA, whichever way you want to say it, as the biggest side. Alright, one more property about these triangles. In a triangle, two sides must sum to be strictly greater than the third. Every time. That means if we add two sides together, it has to be bigger than that third side. If it's not, even if it's equal to it, it is not a triangle. It is not a triangle at all. So, here we have three examples. We have a triangle with sides 3, 4, 5, 2, 4, 7, and 2, 3, 5. Maybe they're triangles, I should say, because we're going to test to see. And you have to test all of them until you either prove it false or you've tested them all and they all work. So, we need 3 plus 4 to be greater than 5. Not 8. 7 is greater than 5. That works. We need 4 plus 5 to be greater than 3. 9 is greater than 3. And we need 5 plus 3 to be greater than 4. 8 is bigger than 4. So it works. So this is a triangle. Two, 4, 7. We need 2 plus 4 to be greater than 7. Well, 2 plus 4 is 6. 6 is not greater than 7. So right away we know it doesn't work. Even though 4 plus 7 is greater than 2, and 7 plus 2 is greater than 4, because that 2 plus 4 is not bigger than 7, this is not a triangle. So we go over here to a third one, 2, 3, and 5. 2 plus 3 greater than 5. 2 plus 3 is 5, but 5 is not strictly greater than 5. It's equal to, but it's not greater, and we need it to be greater. So it doesn't work. And again, it doesn't matter that 3 plus 5 greater than 2 works, or that 2 plus 5 greater than 3 works. Because this one instant does not work, the whole thing is broken down. So there are our triangle inequalities.